Hello everyone. I was recently given a bunch of 555 timers. I have 10 of them. They're all these NE555Ps from Texas Instruments. So I decided that I would make a few videos on them and how they work, mostly because I haven't had a chance to play with them before. Here we have the data sheet for the 555 timer from Texas Instruments. It's a 555 precision timer, and the NE555 is what we have. These devices are precision timer circuits capable of producing accurate time delays or oscillation. In time delay or monostable mode of operation, the timed interval is controlled by a single external resistor and capacitor network. In the astable mode of operation, the frequency and duty cycle can be controlled independently with two external resistors and a single external capacitor. And what we're going to be doing is using it in astable mode in this video, just so that we can blink an LED. And it shows some applications over here that it can be used for. It's capable of syncing or sourcing up to 200 milliamps. And they have a simplified schematic here. It's a common misconception that the 555 circuit is named for these three resistors here, which are all 5K resistors. In reality, according to the creator of the chip, the naming of the chip was done by marketing, and it had absolutely nothing to do with the actual building of the chip or what was inside of it. It was just the next name in a sequence of ICs that they were creating. So the 555 is a very, very common chip these days. Over 1 billion of them are produced each year, and they're used in pretty much everything. So pin 1 is ground and pin 8 is VCC, which is the input supply voltage. This is where our positive is going to connect, and this is where our negative is going to connect for our circuit. Then down here it describes the other pins. So pin 2 is the start of timing input. Pin 3 is the output of the circuit, so that's what we're going to be using to drive the LED. Pin 4 is the reset pin, and this one has to be pulled high in order to keep it from constantly resetting the chip. So sometimes people will leave the reset pin floating, which means not connected to anything, but it's highly recommended that it gets connected to the VCC and only pulled low when you need it to reset the whole chip. So pin 5 is the control pin, and it's recommended by Texas Instruments in this data sheet somewhere that you use a capacitor to bypass that to ground if you're not using it. Unfortunately, they recommend using a 0.01 microfarad capacitor, and I don't have any 0.01 microfarad capacitors, which would be 10 nanofarads, and I don't have a 10 nanofarad capacitor for it. But it is okay in most circumstances to leave the pin 5 disconnected. Pin 6 is the threshold pin, or the end of the timing input. Pin 7 is the discharge pin. It's the open collector output to discharge timing capacitor. This page has the absolute maximum ratings for the chip. So maximum supply voltage is 18 volts. So the chip can handle 4.5 to 18 volts, which is one of the reasons it's so handy. The input voltage maximum is the same as the supply voltage for these pins. Maximum output current is 225 milliamps. Then we got the thermal impedance. Case temperature for 60 seconds maximum is 260 degrees Celsius. Pin temperatures for 60 seconds, 300 degrees Celsius. And down here it has all of the recommended operating conditions. So it recommends 4.5 to 16 volt max. It recommends a maximum of 200 milliamps. And it recommends keeping the device under 70 degrees Celsius and above 0 degrees Celsius for the NE555. And this is our astable 555 circuit that we're going to be building. So we have VCC here, which is connected to the reset pin, which is pin 4, and connected to pin 8, which is the actual input pin. We have pin 7, which is the discharge pin, connected to the middle point between two resistors, resistor R1 and R2. This is what controls the oscillation timer and the duty cycle. Then we have the threshold and trigger pins tied together, so that's pin 6 and 2, and they're coming over here to after resistor R2. Then we have a capacitor here, which is the discharge capacitor, and then that goes to ground. So then we have pin 1, which is the ground pin, which is directly connected to the ground rail. I'm leaving the control pin disconnected, and then we're going to have the output pin going off to an LED. So since we're just building a basic LED circuit here, what I'm going to use is I'm going to have a 1 microfarad capacitor. Resistor R1 is going to be 1K, and resistor R2 is going to be a 680K resistor. So that should get me fairly close to the LED being on, the same amount of time that it's off, and about a 50% duty cycle, I think, and almost 1 second total, so it should be on for somewhere in the 400 milliseconds and then off for somewhere in the 400 millisecond range. I have a 555 timer here on this breadboard. I also have a breadboard power supply here that's set to 5 volts. I have this side of the breadboard power supply turned off, which is okay because I'm only going to be using the negative rail from this side, and that is still connected even though the jumper is off. All the jumper does is turn on the plus rail here. So this power rail here, the plus on this side will be 5 volts, the minus will be 0, and the minus down here will be 0. So first pin 1 goes to ground because pin 1 is the ground pin. Then we're going to connect pin 2 and pin 6 together. And the capacitor is also going to be connected to pin 2 here. The negative side of the capacitor is going to the negative rail. And this little capacitor is 1 microfarad. I'm going to put the resistor in here, and this is the 680,000 ohm resistor. This resistor goes between pin 7 and pin 2. Now I forgot to mention there is a little circle here that denotes pin 1, and there's also a little crescent shape on the chip. So pin 1 is here, then it goes pin 2, pin 3, pin 4, then we come over to this side and we have pin 5, pin 6, pin 7, and pin 8. Next up we'll do pin 3, which is simply the output pin. So really this one can connect to anything. Pin 4 is the reset pin, and it goes to the positive rail. Pin 7 gets directly connected to VCC through a 1K resistor. These are our timing resistors now. So VCC comes into the 1K resistor, which goes into pin 7. Then pin 7 is also connected through a 680K resistor over here to pin 2. And finally here we have pin 8. I have to move these out of the way a little bit. Should have put this one in sooner, but it'll be fine. Now, in addition to these, it's also recommended to use a decoupling capacitor here. I believe it's a 100 nanofarad decoupling capacitor they recommend, so I have this ceramic capacitor here that's just going to go between the positive and negative rails. So now we can take the output and we can connect it to a LED. Now, all things being equal, if I plug in the circuit board power connector and turn on the light, you can see the LED is blinking. Now the interesting thing is, if you remember from the data sheet, it said that the 555 timer can both source, which is what it's doing here, it's sourcing current to the LED, and it can also sink current. So that means we can also connect another LED here, but connect it the opposite way, so we'll have the positive coming into the LED and then the LED terminating here. And when we do that, you'll see that the LED alternates on the opposite side of the oscillation from this one. There we go, we now have two LEDs. So when one's off, the other is on, and when one is on, the other is off. And you can easily change the speed at which they're blinking just by changing out this resistor here. The 680K, I can make it longer by adding more resistance, or I can make it shorter by taking away resistance. But this is easy to see that it's working. And we can take a look with the oscilloscope at what the waveform looks like here. So you can see that this is 1 volt per division vertically here and 0.2 seconds horizontally per little square. So this one's captured fairly well. So we've got 1, 2, and a tiny bit. So that's probably about 0.5 seconds there. Maybe a little bit less than 0.5, maybe 0.43, I think would be about how many seconds they're on for. So it looks like it's going from about 0 volts up to about 3.3 volts on each of its little cycles, which is more than enough power for these little red LEDs. All in all, it really doesn't take very many components to make a 555 timer blink some lights. Really, it's just the capacitor, the two resistors here that control the oscillation rate, and then the lights themselves with proper current limiting resistors so they don't get overdriven. Because if you sent 200 milliamps through one of these LEDs, it would just instantly burn out. It's an order of magnitude more than they can handle. And the decoupling capacitor is good to have, but I have run this circuit without it and it doesn't seem to make any difference. But it's always good practice whenever you're dealing with an integrated circuit to always put in that capacitor there. And it should ideally be as close to the positive and negative pins of the chip as possible. So that's pretty much it for this episode here. I just wanted to build up a little blinking LED circuit just to start understanding how the 555 works. Now the other thing I can do is I can swap out this resistor here. Which I'll turn off the circuit first. Don't actually have to turn off the circuit, but it's probably a good idea. And you can see the LEDs blink way faster. And if you disconnect this resistor while it's on, the LED will freeze. The little 555 timer will stop its work. And you can actually use that to hook that up to a switch and trigger it so that it only steps once. Which is interesting. I hope you found this episode of Tinkering with Terrius interesting. It was a fairly basic look at the 555 and didn't have too much explanation about the chip itself. I plan on doing that in a separate video. So if you haven't already, then please consider subscribing to my channel. If you liked this episode, then give it a thumbs up. If you didn't like it, a thumbs down. If you have questions or comments, please leave them in the section below, or you can email them to me or tweet them to me. If you'd like, feel free to share this video with your friends. Thank you for watching. I hope you have a wonderful day.